Science is inquiry. It's what's for your students. But what does it mean? Science is inquiry means that students ask scientific questions, use evidence to answer them, turn that evidence into explanations, connect that evidence to scientific knowledge, and communicate and justify explanations. Notice what's missing, memorization, learning what has already been proven, and a narrow focus on individual science practices. This is not your mother's science. The emphasis is on evidence, and evidence can be observed, gives credence to a statement or position, and is a fact, not an opinion. Science is inquiry, celebrates uncertainty, is adaptable to change, is open to possibility, is cooperative, and is intrinsically motivated, just like play. So what might this look like in your child's classroom? It might look like a supply tornado, and that's okay. Messes can be cleaned up, and science isn't tidy. The idea behind inquiry learning is that we are guides while the student researches, investigates, explores, tries, and oftentimes fails. Students are encouraged to talk to each other, ask questions, discuss, and debate. This will not be a quiet setting with students sitting at their desks with a worksheet. It may have a maker space with supplies that can be sorted, organized, and used to create something. Those somethings can be stored on a work-in-progress shelf for further exploration at another time. We as teachers are tasked with presenting real-world problems to students and encouraging them to work together to find solutions. If we have done our jobs right, students will be excited about the topic they are exploring and will come up with questions they have and not ones that we are suggesting that they have. When learning is tied to an inquiry or question, it has a much better chance of taking root and holding on to our attention. So what can you do at home to help? Don't tell your child what to see or look for. Instead, ask questions and encourage him to do the same. Play with shaving cream and talk about how it feels. Make slime. Try different recipes. Mix and blend unlikely ingredients. Make a mess. See what floats and what sinks. Explore what water does in different containers. Poke holes in those containers and see what happens to the water then. Use Legos, cardboard, pool noodles, milk jugs, whatever to make ramps and send different objects careening down them. Talk to your child about clouds, swings, grass, wheels, concrete. You get the idea. It's all around us. And stop talking. When we talk too much, we keep kids from exploring the path, and we sometimes end up taking over. This can make them dislike the exploration. Back off. Let them lead. Here are a few helpful apps that can be fun for you and your child to explore together. Science is inquiry isn't something kids just do at school. It isn't going to come home in the form of a packet or a worksheet. Science is inquiry is daily life. It's finding moments to ask, what if? Or what do you think? Here's a good example of inquiry learning in a sample lesson from MysteryScience.com called How Do Animals Make Their Homes in the Forest? In the read-along mystery, Who Lives in That Hole?, Desiree notices all the holes in the trees around her house and sets out to discover how they got there and why they matter. Students can take a nature walk. Take some time to sit quietly outside, in a park, on the playground, or wherever you might be able to see the animals that live in the neighborhood. Have students watch for insects in the grass, birds in the trees, squirrels scurrying across their path. Make a list of all the animals that everyone sees. Take a walk and carefully watch for places that animals might make their homes, from nests and tree holes to spaces under logs and rocks. Be sure to stay safe and make sure students look, but don't touch, as they take their nature walk. How is this inquiry learning? Well, it doesn't tell kids what to find. Rather, it offers open-ended questions to ask children to engage their thinking and encourage them to probe further. Also, the assessment provides a way for students to show what they learned, choosing an animal and showing its home. It does not say what animal to choose, but rather allows the student to choose. Now we'll take a look at a lesson plan from Planet H2O that needs a few tweaks. Teacher writes the word cycle on the board. Students write responses to the following questions in their science journals. What images are suggested by the word cycle? What shapes best represent cycles? Have you ever heard of the water cycle? Now let's give it a little inquiry makeover. Ask about puddles and students' experiences with them. Relate the material to personal experiences that are fun for the students. Have students simply report what happened rather than answer specific questions. Back to the original plan. In small groups of 3 or 4, students share their answers and create a flowchart demonstrating the water cycle. Share responses as a class and create a class water cycle flowchart on chart paper to display on the wall for the remainder of the unit. And for the makeover, refer back to those puddles of their playtime and use an experiment that might involve water in a cup, but that water could still be a puddle to jump in. In the original plan, teacher passes out the illustration of Thurston's water cycle adventure. Students use guided questions and discuss in small groups whether the illustration does a good job of showing the water cycle and thinking of ways it can be improved. In the makeover version, teachers could ask questions like, what if we added dirt to our water? What would happen then? The teacher would encourage students to think about other what-if questions they could ask as well. At the end of the original plan, students use reflection questions and they analyze the model. Then finally, they discuss what happens to the model and add to a chart telling what they learned. In an inquiry makeover, the conclusion activity could be to talk about what happened and ask questions about it, maybe even questions that we don't know the answers to. The extension activity could involve making more real-world connections that apply to the students. Let's look at a few other inquiry science lessons your kids could do in our classroom. In Could You Build a House Out of Paper?, students will explore the physical properties of paper and experiment with different ways it could be used to change its strength and flexibility. In this activity, each student will build 2 towers using 3x5 index cards and paper clips. First, students build tall towers. Then, they take those towers apart and build towers strong enough to support a hardcover book. Students will report their findings and explore other questions they may have, and take a journey through a lesson that guides students through foundational concepts for structures. Another lesson would be Sound Effects Artist. In this lesson, students will explore how vibrations make sounds that they hear in cartoons and movies. Students will use their hands and feet to make the sounds associated with wind, light rain, and heavy rain, as well as a bouncing ball. They will then watch a silent video with both effects and will add their own sounds to match the video. Students will explore other ways to make sounds they hear in cartoons or in movies. This lesson will guide students through the science of sounds and real-life application of that principle. I hope you enjoyed learning about science as inquiry, but what I hope most of all is that you left with a lot more questions that you could be asking. An inquiring mind is a learning mind after all.